Hello again. Welcome to the ESA Lab at CH Igluna project live stream. This project is coordinated by the Swiss Space Center and supported by the European Space Agency and the Swiss government. My name is Gilles Feusier and I'm working with the Swiss Space Center. Now I'm very pleased to introduce you the Igluna 2020 project Team 16 rover. This team is coming from the Politehnica University of Bucharest in Romania. The project on which this team worked is a very challenging rover, in fact, a full system that shall be able to map its environment autonomously. Today, the team will present its project during about 30 minutes and will then answer to your questions until the end of the session, which means we will end before 2 p.m. Swiss time at the latest. For asking your questions, please use the YouTube chat. I will then forward them to the team. You can, of course, use the chat during Team 16's presentation. I'm sure you will be very interested by the description of this complex and miniaturized rover. Hello, Catalin. Rover has landed. Please let us discover its impressive features now.
Hello from Bucharest. My name is Catalin.
Hello, guys. My name is Bogdan.
And we are the part of the rover team that's working on our system. And today I'm going to show you the presentation of our rover, our concept, our design, all his subsystem, his functions, and his role, and why did we choose to do this design. So, remotely operated vehicle for environmental reconnaissance. It's the name of our project. This is our team. We are a group of students from the University Politehnica of Bucharest Faculty of Aerospace Engineering. Myself, Catalin Pascale, I'm the project manager. Right beside me, it's my colleague Rusu Bogdan. That's
the design lead
for the project. Also, Professor Constantinescu, that's our project advisor. Raul, that's our manufacturing contract, and he's a BCC student, as well as Andrei Avramescu, and also Laura, that is her responsibility is
marketing.
Okay.
Also for the project.
So why we are doing basically our rover can be useful. So our rover can provide necessary information to assess the feasibility for further exploration. So in terms of setting a base, you can prospect the area before you want to build a lunar base, or you want to make a mining operation. You can assess the terrain and also the composition of the rocks before you start that mining operation. Or you can do a potential landing site. You can send our small rover and do a survey of the area to see if that area is feasible for a landing site. Why it's our rover special comparing to the others rover? So we build our rover only with off-the-shelf components. It's very easy to assemble. It's cheap to manufacture because using off-the-shelf components is cheap to manufacture. Also, being light and cheap, in one launch, you can send multiple rovers and then land them on multiple locations. So you can cover a large area and take samples and prospect a lot of zones before you decide on a mission, on a location of the mission. How we want to do this? So first of all, by autonomous navigation, and by autonomous navigation, I mean that the rover can take decision about its route to the desired destination, and the decisions are taking by the software that's controlling the autopilot. We want to collect environmental data and also stream this data to the control station, so you can take a decision about the area that you are interested in. And also we want to display the telemetry data and information from the sensors that we will put on our rover on the control station. The control station can be down to earth, or a remote control station that's orbiting the moon or Mars. This is our concept, our rover. It's inspired from the Curiosity rover. You can see the two main sensors that we have right now. So you can see the LiDAR sensor that you can see also on the rover. This is a high quality LiDAR system, and also the FLIR camera, and it's mounted on the gimbal. These two components will be fitted on our rover. You also can see some other detailed components that are mounted on the rover. Later I will present you a little bit more about them. You can see here how our rover scales comparing to an average human being, and also how it is compared to the Curiosity rover that's on the Mars right now. In this slide, you can see on the top side of this slide, you can see the rovers that are already on Mars, and on the bottom side, you can see the lunar rovers. Sojourner, a small rover, it's a 10-kilogram rover. Our rover is a 12-kilogram rover. The Mars Explorer, it's an 150 kilograms rover. And of course, Curiosity, that's an 900 kilograms rover. You can see that our rover, it's in the weight size of the Sojourner, but its wheels are as big as the Mars Exploration rover. So we choose this design for the wheels because having bigger wheels and a large clearance comparing to that are mostly the same with the Mars Exploration rover, we can overcome most of the terrain on Moon or Mars. Okay, now I'm going to show you a video with our rover, so you can see some details. Okay, so you've been shown an round view of our rover. Now I'm going to show you some other systems that are connected to our rover, and that make our experimental model work to be tested here at our university. So you can see the batteries that we are using, and the battery chargers. We can see the RF data link module that's it's used to communicate with the rover. It's a really long range RF data system. Also, you can see an additional joystick and throttle system that you can use in case of if you need to control the rover manually. But this is not the case having an autopilot. Those are only for emergency situation, let's say so. And also the computers that you need to use to receive the telemetry data and from the autopilot, and also the data from the sensors. Here you can see details about the dimensions of our rover, about its components, to make an accurate impression of the size of the rover and its body and wheels. And also The mass of the rover, as I told you before, is 12 kilograms. Why we use this locomotion system? So we first, our idea was to use 4 wheels, but we understand why NASA choose for Curiosity the 6 wheels suspension system, because it can keep the sensor platform stable while going on rough terrain. So for a LiDAR system, it's very important to have a stable platform to take accurate data and to make an accurate image of the environment. Terrain obstacle overcome, you can see I drawing a cartoon that the rover can go through small obstacles, let's say, but if it encounters a big obstacle, then our terrain obstacle avoiding system will come into action. The rover will have 8 sensors that will cover a 360 degree around the rover and will make a map that will be connected to the autopilot, and the autopilot will take decisions about going around the obstacles based on the programming that we will do before. Here you can see a slide that shows you the interfaces for the telemetry and data from the sensor to travel from the moon or Mars or whatever the case is to Earth. So we will use, our rover will use an RF data link to a base station, and that base station will communicate with another base station on Earth, where that base station will have the necessary equipment and also the control devices to plan a route for the rover and receive all the telemetry data from the rover. Okay, I'm going to show you some subsystems. This is the thermal video camera that we can use for this project, and it takes high detail video images and also FLIR images. That's thermal vision images for the FLIR, for the people that are not familiar with this. Also, you can see our data link. Our data link gathers data from the LiDAR system and also from the camera, and send it to the base station, and the base station further send it to the downlink to the Earth. This is our autopilot that we will use for this project to test our system. It's a commercially autopilot that's pretty accurate, and we already tested it. Works really fine. We have really good results with this autopilot. Here you can see the servo system for the steering. So we are using 4 servo motors for the steering. All the wheels on the corner of the rover are steering. So the wheels in the front are steering in the direction the rover is going. The wheels from the back are steering in the other direction, so the rover can take really tight turns. And also the wheels inside the curve are going to spin with a slower speed comparing to the wheels on the outer part of the curve the rover is making. So we have a differential speed between the wheels on the left and wheels on the right, depending on what is the direction of the rover. Okay, these are all 6 wheels have independent servos for the traction system. So if one of the wheels can get stuck into an obstacle, then the other wheels will going to compensate for that wheel. So our traction system is redundant. Okay, this is our power system for testing purposes. For now, we are using DJI batteries that are intelligent batteries. They are also heated batteries to keep them on a constant temperature to provide the constant power flow for our system. We have some DC-DC converters to power all the servos that are driving the rover and also steering the rover, and another power converters to provide power to the autopilot and to the RF data link. You can see here a general schematic with all the systems on the rover and how they are connected. So you can see that all servers are powered from the DC-DC converters. All the servers are on PVM. They are commercial servos, so they are off-the-shelf components. Also, you can see how the LiDAR system and also the camera system are sending their telemetry and their data to the rover RF module. And also you can see some examples for the ultrasonic sensors that we are using to for our avoidance system for the obstacles. Okay, again, a detailed list with the heat generated by our systems. I can tell you that we don't have a problem with the heat inside the rover, because only the red components are inside the rover, so they are generating heat inside the rover. So they are about 18 watts of heat inside the rover, so we don't have any problems with heat inside the rover. The other components are mounted on outside the rover. This is our data link architecture. So basically how it works, the LiDAR system and also the video from the FLIR system are going to a micro router. The signals are combined and then send it to the RF data link. The RF data link sends the information to the other RF data links from base station that will send further the data down to earth or whatever where is needed, or whatever the control room is. Okay, now I'm going to let my colleague to present you some specifics about our mechanical subsystem.
Yeah, thank you, Catalin. Hello, guys. I'm Bogdan. I'm going to tell you about something about the mechanical subsystem of our rover. So the idea was to make our rover robust and lightweight for, especially for a space mission. And we want to simulate all the challenges and the capabilities that we can have on making our product, let's say, feasible. So we took a robust design and easy to mount, to assemble, and easy to access, because it has different configurations on different type of missions. You can just put other instruments or other sensor inside it by changing only some minor structural elements. As you can see in this picture, the wheels assembly from the left hand and the right hand are completely detachable, and also the brackets and the FLIR camera and its gimbal system, they are come out of the box. So now I'm gonna show you another video with our project that you can see what's inside the box. So I'd like to share more about our main box and structural elements. So as my colleague mentioned, we try to use a lot of off-the-shelf components to make it easier and to benefit from the advantages of 3D printing technologies, and to make our product, let's say, easy to manufacture, cheap and cheap. So you can see here that we used some carbon rods that you can find them on the market. They come to different sizes and dimensions. We also use some metallic parts that are for fixing the structure and for the locomotion system to put the moving elements together, such as bearings. Here you can see the locomotion system, some structural elements for it. We use the advantage from the carbon rods that we can transport and integrate wires inside them to the structures, so that we can couple the servos and other sensors from the exterior of the rover to the inside box using these carbon tubes. Also, you can see here the wheel assembly, an exploded view of the major components and how everything is fitted inside. You can see that we try to make it lightweight and also fail-safe. So because you can see the system is redundant, we have two slots for bearings and from other structural components. Also, about the differential system, you can see here that we use some rods that are metallic. These are the rods that, let's say, sustain most of the loads from every loading case our rover detects. And I will show you some more about what we've done using our software equipment. So we try to make some structural optimization by increasing the stiffness of the components and also decreasing the mass to make it more lightweight. So I can show you about the brackets that we used 3D softwares to decrease mass by 30%, mostly for all the brackets, and this comes from all the components. And also for the wheels, because the wheel, as you see here, is the third and the fourth iteration. So the wheel on the right side is the last design we are going to use. It will be 3D printed from elastic material called rubber material called TPU. Yeah. So this is going to be done with our with the help from our partners from New Technologies. Regarding our future step for the project, we would like to finish our project to build the rover, and this year it will be ready. And it's almost done, and almost to also to disseminate our project within the conferences that for the moment these are the conferences that we can go because we are not limited from the, let's say, external cases such as the virus. We have these conferences held at INCAS, which is the Institute for National Aerospace Research in Romania. You are also invited if you want to present your papers or something like that. So it's going to be this year in autumn, and for the next year we are going to test our rover at Igluna 2021 field campaign in Pilatus.
If you are accepted.
If we are accepted, of course. Yes. Yeah, it will be our pleasure to demonstrate our capabilities and to demonstrate our work from the last year and our systems. So in the end, we like to thank you all for the support, and also to thank our sponsors and our partners for helping us with the ideas, with the manufacturing,
And supporting us financially for building the rover and getting all the parts and the components in this situation with the all around coronavirus. It was a little bit harder to get the components, but we did manage to
Yeah, we
get
have
most of them
most of
right
them
now.
are
So there are some
here.
just some servers that are missing, but we have almost everything. Everything is printed. Everything, most of it is assembled. So we hope that by the autumn that we can start testing our rover in the field. So thank you for
This was
your
our
patience.
presentation. Thank you for your patience, and see you.
Thank you. Thank you, Rover, for this detailed presentation. Very interesting and complex system you are presenting. Dear listeners, do not hesitate to continue to post your questions on the YouTube chat. And I have now a first question to the Rover team. Why wheels and not legs?
Yeah, wheels. Why the performance off-road cars are using wheels and not legs? So because they are working really good on rough terrains. The suspension system is so advanced that you basically cannot run with the speed of a car on rough terrain. So not even on a let's say a Lion or can run so fast on rough terrains as a speed buggy, for example, that has wheels. So and also because having legs, you have a lot of moving components. You have to have more servos, more joints, mechanical components that can fail in a dust environment as the moon is. So wheels, we think wheels is better.
By the way, another question with the speed. What speed shall your rover run?
Between 2 and 5 centimeters a second. So it will not be fast, but it's from the point of view of energy consumption, it's really advantageous for this speed.
Thank you. I have now another question. Is your rover optimized for Moon or Mars? Or is it versatile to be used in many planets, moons?
For our rovers to be used on Moon or Mars, we have to take into account two aspects. First of all is the power source. That in this configuration that we're testing now, it's not viable to use it on the moons on the Moon or the Mars. So the best thing for this kind of application would be an RTG generator, but we have some troubles getting plutonium to build that right now. So there is no we can test it. But if this concept can be it's chosen for a mission, an RTG generator would be great to integrate on it. And also we have concerns about printing plastic and using it in space where radiation is a problem, but I think we have that covered. There are some papers that we read that already people are starting to use printing materials for CubeSats, and seems like they are working. So I think we have this part covered. So the only problem would be the power source.
Yes, okay, thank you. Maybe a related question. Have you accounted for the extreme temperatures, both minimum and maximum, that the rover could experience? How this could affect electronics and perhaps a rover chassis?
The rover chassis should not be influenced by these temperatures. They are already regarding bearings. There are already bearings that are space-proven bearings that can work in a space environment. Carbon fiber also has no problem. Chassis of the robot is composed from carbon fiber and printed materials. Also, the printed materials, as I just explained, can be used in space. It's proven. It's used for CubeSats. The carbon rods have no problem in the space environment. About the electronics that we use here for testing, it is not space rated, but it's redundant. So instead of one accelerometer, we use 3 accelerometers. Instead of one magnetometer, we use 3 magnetometers. So the system is redundant. It's basically the same system that SpaceX is using. The SpaceX is not using space-rated components. They are just using a lot of them that work in parallel. So they each correcting each other if problems appears.
Yes, maybe again related to that, to what you just explained. If being deployed in the moon, how much time could it stay there? What could be the factor that will end the rover's life at the very end? Radiation, temperature, electrical charging?
I think the power source would be the main factor that will end the life of the rover.
Okay, thank you. Have you also considered how it would be safely transported to the moon?
Yes, we also have a detailed design about putting our rover into a capsule, and also Bogdan has made some tests about the forces involved during a launch. 9G.
Yeah, because during the launch you have a lot of vibrations. Also, when the rocket gets in the upper stages of the atmosphere where Qmax appears. So you have a lot of vibration, and you have to, let's say, correct the natural frequencies from the rocket with a capsule that contains our payload, which is the rover. So we have to make the structure to resonate at higher frequencies than the launcher resonates.
We have a modal structure analysis for the launch system, for the capsule, for the structure of the capsule for the rover.
Okay, very good. I think there are a lot of interest about the specific environment, space environment, because there is another question. You are using off-the-shelf components, and do these components have variations available for radiation-hardened specification? If no, how do you plan to update your components for lunar application?
So the only components that can be affected by radiation, let's say electrical components, because structural components were already covered. Electrical components that can be affected, let's say the servers have no problem with the radiation. The most sensitive component is the autopilot. The autopilot, we build for the autopilot a separate case that you can build it in a case you launch it from a material that can isolate the autopilot. So the autopilot has a special case. It's put in a special case.
Okay. Now, with more the mechanical side, what strategy have you used for dealing with the thermal expansion of the different materials when being assembled together? Thermal expansion, yeah, because you have various materials.
Yes, but we print some samples, we test them, and then we adjust them accordingly to how they expand. So the final assembly, they fit together perfectly.
Yeah, we optimized some tolerances from our parts before we have the final assembly. And also, this is a demonstrator project. So if we want to launch it for the moon, we have to make some modification to fit those challenges. Yeah.
Okay, and so you in fact already participated in INGLUNA 2019. Have you used some of the technology of last year for your rover?
No, only 3D printing, because that was a really different challenge. That I think the last year project was more challenging, because for the project from this year we had some examples. Someone did that before. There are some rovers on the moon and on the Mars, but last year project was like a prototype that no one had done this before. That was a little bit more challenging. And the only thing that we used from last year was our expertise that we acquired during printing parts. So I think that's basically the only thing.
And also system management and system engineering features that help a lot.
Okay, that's good. And again, a technical question. Have you already thought about the outgassing from the different materials you are using?
Yeah, there are already some papers. I found on the internet some science papers with materials, with composite materials, printed composite materials that are space worthy. So they can be printed, launched into space, into orbit, and they are not changing their properties. So you actually can print some special plastics that are not affected by radiation or gassing.
There exist plastics, but for example, you use a specific material for the wheels. The wheels, for example, did you find these materials specifically?
No, for this
you have to change.
For this one, for the wheels, we didn't find yet a material that can be printed. But for the wheels, we have an alternative. We can make them from steel wires, also elastic to have elasticity, and also lightweight.
Yeah, the material for the wheels is relatively new, and it's from a couple of years before. So the guys who are helping us, New Technologies, have this material from, let's say, 2 years or something like that. So it's a lot of work to be done on optimizing this material for space applications from now on.
Yeah, sure. Then with the configuration, again, with the wheel configuration, does the 6-wheel configuration keep the box balanced if the right-hand wheels are at higher elevation than the left-hand side facing on a hill? So if you are moving...
animation.
Actually, it's like it makes the medium between high differences and keeps the box in that medium height.
Okay.
You can it was an animation on the beginning of the presentation with the rover and the suspension system, and the rover is going through with its wheels on different slopes, and the box was fixed in the middle. So that's the advantages of this suspension system, that you can keep
actively or passively fix this position.
It's passively. It's balances it itself.
But it also can be actively, yes, with using some actuators or something like that.
Now, maybe another question. I don't know if you thought about that. What is the ecological impact of your technology compared to the other rovers?
To be honestly, we didn't think about that. Ecologically, about referring to that building in mass production the rover, or that you can put.
I don't know exactly, but maybe also related. You were speaking of RPG. Maybe it's not the cleanest technology to send on a planet. Maybe I don't know what is behind the question.
Yeah, I don't think it's biodegradable, our rover. No, you cannot chew it.
And maybe discussing on the power, because I think I see a question about that, and I don't know if you watched the presentation of PowerHub team this morning. Yes. And the question, why not using a radiant energy reflector and charge the rover with wireless power transmission? In this case, the lifetime of the mission will be heavily improved. You know this wireless power transmission.
Yes, but only if you are using batteries. If you are using an RTG generator, you don't need for this. And also, you have always to come back to a base station to charge after you depleted, or after half of the batteries are depleted. But if you are the rover is equipped with the RTG generator, then you just can go wherever you.
I think what was presented by the Glasgow team was to get remote wireless power transmission. In fact, this was a very interesting solution as well. So Maybe next question is, what would be the most important lessons learned you take with you after this year in Igluna?
So time management, it's the first. Yeah, and risk assessment, because as you know, we had some delays from the situations, but managing everything in time and mitigating some actions can help to optimize our project until the end. So we consider that for our project.
So we basically we learned that a small virus can overthrow your entire project.
Okay, and another question, we were speaking of the batteries and the wireless. There is a question related to the battery. For how long the batteries will hold, and how are you planning to recharge them?
So we, as I told you, if it's going on a mission, batteries are not suited for this application, but during test, we have spare batteries, have battery chargers. You can change the batteries. Both batteries can be changed in less than 20 seconds. So we can do a survey mission for tests. The rovers comes to the base, or another person with the batteries can be on the site. Just change the batteries in less than 20 seconds, and then just you can go on. Also, you don't have to disconnect the telemetry and the autopilot, because the batteries are in parallel. So you can change one battery, put a new one, then you can change the other one, and then just we can continue the mission. This is only for testing purposes here that we'll do before you can say you can space rate this rover.
Okay, now I have a question related to the navigation. I think you implemented a GPS solution in your system, and how do you deal with the lack of GPS on the Moon and Mars? Do you have a localization software implemented?
Yes, we think about using multilateration system, using all the satellites that are already orbiting the Moon or Mars. So the positioning will not be so accurate, but you can still have a good idea about where the rover is. Also, you don't need to know exactly where it is, because it has its own autonomous navigation system that it's aware about its environment. So you just need to tell him where is the general area you need to go, and then also you have live video data stream, of course with the delay, but you can see if that's the area where you want your sensors to be in, and you can correct the position on the spot. But trilateration using the satellites, the artificial satellites orbiting already the Moon and the Mars would be, I think, would be a good solution for replacing the GPS. Mostly that you don't need to have a meter accurate position, because there are no roads, there are no buildings. So if you are 20 meters on that side or that side, I don't think it's a problem. And then you can correct that with using the video feedback system.
Mm-hmm. Yeah. Maybe also a question related to your concept. How much can your product be even more miniaturized? The dimension and the size, could you miniaturize it? Could you reduce its size?
We can reduce its size, but we will go back to the power source, because you cannot build a small RTG generator. So that will be practically the main load on the rover, the main payload, and the most heavy structural, the most stress on the structure. So of course, regarding sensors and autopilot, of course you can make it smaller, but as you saw on the pictures the beginning of the presentation, our rover, it's already in the smallest class of rovers that were sent to the other planets. So if you are using an alternative power source other than an RTG generator, then yes, you can make it a little bit smaller. But if you make the rover smaller, then maybe you want to make the wheels smaller, and making the wheels smaller will not benefit you in overcoming obstacles without going around them. But if you have bigger wheels, you can just go over the obstacles, not go around the obstacles.
Okay. Then maybe a question, you have a lot of sensors on your rovers, and you are aware that there are a lot of dust on the moon. So how you take into account this dust? Did you implement some kind of self-cleaning option on your rover?
No. Basically, the LiDAR, yeah, there is a lot of dust, but there is no one that's making dust there, because there are no people and cars running around. So there will be dust mainly on the wheels and the servos, and the servos are sealed, are tightly sealed. The LiDAR system, that is an optical component, the precision, it's on the top of the rover. And because the speed of the rovers, it's we are not moving fast at all, then the dust will not go up to the sensor. So the sensors are on top of the rover. The wheels that are, let's say, putting the dust up are down, and they are moving very slow. So we hope we will not face this problem about dust. Of course, on the moon, on the Mars is a different problem, because on Mars we have, of course, an atmosphere, and there are winds, and on the Mars you can have problems about your sensor getting dusty and not getting so accurate. But for now, our system does not have something to blow off the dust. Maybe we can put a little air pump like on it, and just blow from time to time on the sensors. I don't know.
On the moon, air will be a bit difficult, I think.
No, but on the moon you don't need it, because on the moon you don't have winds, so there is no dust putting on the sensor, because your sensors are on top of the rover.
Yeah,
no
maybe,
atmosphere, no
maybe
dust.
some element to be checked. And okay, maybe a last question. Somebody asked you, what can we expect for Igluna 2021 from you guys? So question, what do you expect from the 2021 campaign? What will you bring new on the new campaign?
Yes, we want to bring the rover, build and program it. And also we saw some interesting sites at the Pilatus Mountain, that we can put the rovers to run in autonomous navigation, to go around the rocks, and to have some areas scanned, to get the data to the control room, and to see the results. So the rover will be built. We'll bring our system. Our main system is the rover, and accessories that came with it, mainly batteries and some radio transmission systems. And we want to see how it will perform. If it, of course, we are going to test it before, because we have a lot of time now, because it's a year. So we're going to test it here, and I think for the next year at Igluna 2021, the system will be ready to perform and to demonstrate its capabilities.
Okay, thank you very much. I think there are no new questions, or is a question arising rapidly now? I don't think so. So thank you again, Rover, for this very interesting presentation, and of course to everybody for the interesting Q&A session. I think there were really many questions and very interesting questions. The detailed mapping of a remote location in a harsh environment remains a very complex and challenging task, and the use of your rover for such a task is of high interest, of course. Its use for Earth application may also be of interest for locations where human access is difficult or dangerous. But there is still a lot of challenges to be solved before going to the moon, mainly related to the environment, but also, as we discussed, to the power. So we really appreciate your hard work and wish you all the best for your next steps. With this, we conclude the session. Please stay tuned for the next show with a presentation of the future of moon exploration by the Swiss astronaut Claude Nicollier, coming up this afternoon at 2:30 Swiss time. Claude Nicollier is a very inspiring person. I really recommend you to watch his presentation. For all of you watching through YouTube, please fill in the survey in the video description below. Your answers are very valuable to get to know you better for our future events. Thank you and see you later. Bye-bye. Hello again. Welcome to the ESA Lab at CH Igluna project live stream. Igluna project is coordinated by the Swiss Space Center and supported by the European Space Agency and the Swiss government. My name is Gilles Feusier and I'm working with the Swiss Space Center. Now I have the privilege to introduce you our Swiss national astronaut, Claude Nicollier. Claude Nicollier was an ESA astronaut who flew 4 times with a space shuttle with 2 missions consisting in servicing the Hubble Space Telescope. Claude Nicollier is a physicist, an astronomer, a pilot, and of course an astronaut. And most of all, a great person. He will bring us to the moon and to the future of space exploration. So, Claude, let's go to the moon.
Hello, everyone. Good morning or good afternoon, wherever you are. It's a pleasure for me to be with you again. I talked to you about the Hubble Space Telescope servicing and some results from Hubble last Sunday. And today I will talk about moon exploration. More specifically, it's going to be moon exploration past and future. This session is going to be different from the other one. There will be very little, if any, engineering. There will be little science. It's going to be about inspiration, passion, and interest of bringing people to other celestial body, like to the moon, and of course later it's going to be to Mars and other places in the solar system. If we have listened to the presentation about colonization of space yesterday, it could be even someday to exoplanets, but today we'll focus about the moon. And I decided to talk about not only the future, which was the plan for the original session, but about the past also. I don't say the present because we are not on the moon right now. We were in the past and we will in the future. And this is the outline of my presentation. I'll talk about the inspiration and again, the passion and the emotions. Emotions is going to be a big word in this presentation because space flight, whether it's on a low Earth orbit to the moon or beyond, brings a lot of emotions. I'll talk about Apollo. I'll talk about Back to the Moon, which is basically the Artemis program and what will follow. And I'll talk about the moon for other people, for non-astronauts, because it's coming also. Now, the moon has always been an inspiration source and a dream destination for humans since centuries. At the end of the 19th century, 1865, Jules Verne wrote a book, De la Terre à la Lune, and the idea was to shoot a bullet with people on board and a dog from Florida, by the way, all the way to the moon. That was it was a wonderful story. And again, it was the expression of this dream of humanity of leaving the Earth environment and going to another celestial body. And of course, a natural choice initially is to go to the moon. Now, a little later, about a century later, we had a wonderful story of Tintin, Milou, Capitaine Haddock, Tournesol going to the moon. This is a cartoon which is very widespread in the French-speaking countries. It originated from Belgium. Still, the cartoons in French language mainly come from Belgium, but it was very, very widespread in all the French-speaking regions of the Earth, and also was translated in many languages. Tintin, on a marché sur la Lune. The preceding book was Objectif Lune, the preparation somewhere in Eastern Europe of going to the moon, and then these beautiful rockets with the red and the white squares lifting off from Cile d'Avie with the several crew members on board and going to the moon. This is a wonderful representation of the moon by Hergé. Hergé was an extraordinarily talented cartoonist, and the pictures in this book are absolutely wonderful. On a marché sur la Lune, 1954. By the way, I was 10 years of age when this was published, and this was, for me, I can tell you, a huge inspiration. And now this dream of going to the moon for humanity became a reality with the Apollo program. By the way, this is a picture of the moon with a very, very thin crescent, very close to the new moon, taken from space. Obviously, the Apollo program was launched in this climate of Cold War between Soviet Union and the United States in the early 60s. And we had the first space flight of Yuri Gagarin on the 12th of April, 1961. And in fact, the decision for the Americans to launch a moon program as a response to the success of the Soviet for human space exploration was taken only a few weeks after the flight of Gagarin. The presentation by President Kennedy to the Congress was on the 25th of May, 1961. And that was a very, very bold and courageous political engagement. And the famous speech that you see here was pronounced in September 1962 at Rice University, Houston. And these words are still words that impress me very much. You know, we choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. And I highlighted the next sentence because I think it's very relevant to you, the iGLUNA student, because that goal will serve to organize and measure the best of our energies and skills. And in a way, with this idea returning to the moon soon, still this decade, bringing people back to the moon. And of course, we have had robots already. We'll have more robots in support of this return of human to the moon. In a way, it's the same spirit. That goal will serve to organize and measure the best of our energies and skills. And you, the iGLUNA student, you are part of that. And you can feel the stimulation of doing the best you can in order to help such a program. Now, so this is a spark that ignited the Apollo program. Of course, it went through the years in the early to mid 60s. Then we had in 1968, the first flight to the moon without landing on the moon was Apollo 8. And that's when this absolutely superb picture was taken that inspired so many people. The Earth seen from about 400,000 kilometers away from our natural satellite. And a few months later, this was in July 1969, we had the Apollo 11 liftoff. I like this picture because it shows the people who were gathered close to the launch site, Pad 39A, Kennedy Space Center, and you see this huge rocket, Saturn V rocket, with Neil Armstrong, Buzz Aldrin, and Mike Collins on the small capsule on the top. This is so impressive, and this is an enormous amount of emotion. They are going to the moon for the first time. Now, I just put this picture in between because, again, when I was 10 years of age, this is a drawing by Hergé that inspired me so much. This is a landing of these Tata rockets on the moon surface. Now, now I'm going to be a little bit technical, but not for long, and then I'll go back to emotions later. But this is the orbit around the moon after a trip of about 2.5 days to the moon vicinity. They were coming on orbit around the moon. It was the command module, the service module of Apollo attached to the lunar module. Then there was separation of the lunar module. And two crew members, Neil Armstrong and Buzz Aldrin, came into the lunar module. It separated from the command module and came on a elliptical orbit that has not the perigee, but the peri-moon, in a way, perilune. Sorry, all the text is in French here. The peri-moon just opposite to the point where the separation took place. And this was with the sun low over the horizon and the visibility of the Earth. This is the visible part of the moon, this segment here. And they were trying to land in a place shortly after sunrise in order to have a better visibility, not too high temperature on one hand, and also the features, craters and so were much more visible with a low sun than with a high sun. Now you can imagine they come on this orbit, and here at the peri-moon, they have a velocity of about 1.7 kilometers per second, and they have to do a so-called PD, powered descent. Of course, you don't need to do this when you come back to Earth because of the atmosphere for braking, but here you have to use the engine, the rocket engine, the bottom of the lower stage of the lunar module to do the braking. And at this point here where I show the arrow, there is PDI, Powered Descent Initiation. Then they come down, and eventually they have to come on the vertical orientation of the lunar module for landing softly about 1 meters per second on the surface of the moon. Now I explain all of this because I'll show a video of the approach, and you'll hear at the beginning of the video, you are go for PDI. That's an instruction from a Mission Control Center, Houston. You are go for the powered descent initiation, and they are go to do this little blue segment here. Now you have to imagine they come down. The windows are initially oriented downwards, so they see the moon coming by, and then at some point they need to do a 180 roll maneuver in order to put the windows in front, so they can see where they will land at the end of this descent. So you'll see this roll maneuver in the video, then you see the descent, and you'll hear, because I will not make any comment during the video, there is classical music in the background and the communication between the ground and the crew. At some point, you'll hear 60 seconds. It means they have 1 minute of fuel remaining. When they are very close to the moon surface, you'll hear 30 seconds. They have 30 seconds of fuel remaining. Then there is the probe that touches down on the moon surface. It shut down the engine. And then you have to listen carefully. You hear the emotional voice of Neil Armstrong. Houston, Tranquility Base here, the Eagle has landed. Eagle was the name of the lunar module. Okay, I explained to you a few features so that you will well understand what will come, the video that will come. Let's go to the videos. This is a lunar excursion.
Eagle Houston, we rig you now. You're a go for PDI, over. Roger, understand. At the Earth, right out our front window.
"50,000 feet above the moon, Eagle's descent engine ignited and began the deceleration for landing. As they descended, Armstrong and Aldrin watched the craters and mountains of the moon pass beneath them.
You're a go for landing, over. Roger, understand. Go for landing.
At this point, the Eagle rolled onto its back to give the landing radar surface acquisition. Now the crew was flying blind, hurtling toward the lunar surface. Only their instruments and the voice of mission control telling them where they were, until the slow pitch maneuver brought the lunar horizon to their view.
100 feet, 3.5 down, 9 forward. 5%. 185. 75 feet. That's looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward. Good. 40 feet, down 2.5. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 20, down a half. 30 seconds forward. Just picking up some dust. Got the shadow out there. Contact light. Okay, engine stop. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Okay, here we are. They landed on the Sea of Tranquility, and there was a camera installed on the lunar module showing Neil Armstrong making the steps down on the ladder and putting his foot on the surface of the moon. we walked on the moon for the very first time in history. But in fact, Neil Armstrong was not the first one, because Tintin and Milou, the little dog, and Capitaine Haddock and Tournesol had already been there in 1954. This is a wonderful drawing by Hergé. A lot of humor here. This is wonderful. So this is a real picture of the lunar module Eagle that had landed on the Sea of Tranquility. You see it's a pretty flat place on the surface of the moon. This is a picture of Buzz Aldrin, picture taken by Neil Armstrong, and you see an experiment of University of Bern to measure the composition of the solar wind. It was a relatively short spacewalk, only about 2.5 hours. Then back in the upper stage of the lunar module and back on lunar orbit to meet with Mike Collins, and the three of them returned to the Earth successfully. Now, these are the crew members on this mission. You have Neil Armstrong on the left, Buzz Aldrin. It's interesting to see that you can see on this picture the different personalities, both of them extremely talented people, but different personalities. And the third one, very, very talented also. I have personally a huge admiration for these three individuals who made the first mission to the moon and the first steps on the surface of the moon for Neil and Buzz. Mike Collins wrote a wonderful book, Carrying the Fire, written by himself, not by a ghost, but by himself. And this book was for me, it was published in the early 70s, was for me a huge inspiration to become an ESA astronaut. Now, of course, it was an American success, and they had to beat the Soviets in these steps of space exploration, and they did it brilliantly. But really, the spirit was that there were people from planet Earth coming on the moon. And this plaque was located, still is, in fact, on one of the legs of the Eagle lunar module. Here, men from planet Earth first set foot upon the moon, July 1969. We came in peace for all mankind. And I think this is beautiful. And this is really the spirit of all human space exploration now. People who go into space, astronaut, cosmonaut, taikonaut, they go representing humanity in space. Now the program went on, as you know, Apollo 12, Apollo 13 had, of course, this big problem close to the moon, explosion of the oxygen tank. But again, it was, although the mission goal was not accomplished, it was a huge success for NASA because they were able to save the crew. Thanks partly to the work done in the Mission Control Center, Houston, under the lead of Gene Kranz, the flight director of Apollo 13, a remarkable individual. He gathered his team in the mission control room. He said, we're going to save the crew. Failure is not an option. He wrote a book with the same title. Wonderful individual. Now the program continued with Apollo 14. Apollo 15, I would like to show a short video because Dave Scott, the commander of Apollo 15, made an interesting experiment. On each of these Apollo missions, there was something special happening. There was a golf tournament at some point. There was a mini Olympic Games on Apollo 16. Apollo 15, there's a demonstration by Dave Scott of the law of falling bodies. You remember the law of Galileo, whether you have a feather or a hammer, they will fall and hit the ground at the same time, except that on the Earth, the problem with the atmosphere is such that you cannot well verify it. Dave Scott verifies that law on the moon. Let's go with the video.
Jim, we copied a bow solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. George, you have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our Falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb. Okay, now this same mission, Apollo 15, we had for the first time a lunar rover that was taken, that was tested and utilized in order to increase the the size of the area that was going to be explored around the landing point of the lunar module. And we have here an interesting video showing how rough the moon surface is for this electric vehicle used again on Apollo 15, 16, and 17, the last 3 missions of the program. Let's go. Okay, now we had then Apollo 16 with John Young and Charlie Duke that walked on the moon. Apollo 17 was then the very last mission in December 1972. And I have a quick video showing you the commander of Apollo 17, Gene Cernan, walking on the moon so that you have an idea how they walked on the moon. They didn't walk on the moon, they were moving pretty fast. At the end, he's doing this so-called skip procedure, and you'll see it. Let's have a look. Go.
Whee! Boy, when you do this and you go down slope, that first step is a long one. I'm having... This is the best way for me to travel, uphill or downhill. What's that? Like this, two-legged hop. And on level ground, I can skip. I don't like that loping thing. Oh, the loping's the only way to go.
Checkpoint.
See, when I'm on level ground, I can skip. But this two-legged thing is great. Man, I can cover ground like a kangaroo.
Now, for the first time in the Apollo mission, we had a scientist on board. Until this mission, we had very talented and capable test pilot and with an engineering background also, but not really a scientist. But on Apollo 17, NASA assigned Harrison Schmitt, whom you see on the far left side near this big rock on the surface of the moon. And Harrison, a geologist, wanted to take that big piece of rock back to Earth, but it was a little bit too large. So he used a hammer to get some pieces of that big rock. Harrison Schmitt is a wonderful individual. In fact, we had the huge pleasure of having him on Igluna 2019 in Zermatt last year. You can see him, the second from the left, and we had also cosmonaut Baturin, who is the second from the right. So Apollo astronaut and cosmonaut have been part of the Igluna program, and we hope to have them again, hopefully next year in Pilatus. Now, Lessons from Apollo. If you really, really want it, you can do it. Courage, determination, and the very strong idea to reach goals. Apollo united the world in a remarkable manner, despite being a Cold War program. And since Apollo, really, all the space program have become symbol of cooperation in research and cooperation between countries. And the program had a very deep human dimension, bringing forward at a very high level positive values such as trust, mutual respect among all participants. It was a great program and a huge source of inspiration for all the human space program that followed. Now, this is a nice picture of a good fraction of all of the still living Apollo astronauts. We only have 4 out of 12 moonwalkers who are still alive, and 3 of them are here. The only one missing is Dave Scott. We have from left to right Charlie Duke, Apollo 16, Buzz Aldrin, of course, the second to walk on the moon on Apollo 11. Walt Cunningham, Apollo 7, which didn't go to the moon, but to test around the Earth. Al Warden was the command module pilot on Apollo 15, Rusty Schweickart, Apollo 9 around the Earth. We have Harrison Schmitt, whom I talked about before, Mike Collins, who was the third one on Apollo 11, and Fred Hayes, who was on Apollo 13, of course, didn't land on the moon. Beautiful picture taken at the Explorers Club, New York in March 2019. But there were also the hidden heroes of Apollo, all the flight directors, extremely respected people, and the people who were really determining the fate of the mission and were guiding the whole process in the mission control room, supported by all the specialists in the control room. In fact, you have this is Gene Kranz, this is Ed Fendel, this is all of the flight directors of the Apollo program, most of them are here in the control room of Apollo, which is still kept as a museum at the Johnson Space Center in Houston. So Gene Kranz here is the first one. And another thing I would like to mention is the existence of a small company in Switzerland called Swiss Apollo. And the president of Swiss Apollo is Lucas Viglietti. He's a pilot with the Swiss Airlines. But he has had since a long time a huge interest in the Apollo program, and he has tried to bring together the actors of the Apollo program, whether it's astronauts or flight directors, into Switzerland. He wrote 2 beautiful books. This is the French version, the first one, that was called Apollo Confidential, the foreword by Charlie Duke, and this is a translation in English, Memories of a Man on the Moon. And there are a lot of personal stories of astronauts. I'm going to tell you just one story, but I recommend very highly that you order the book and read it. Some Apollo astronauts were training in Arizona on the Meteor Crater. This was in 1968, and they were met by Navajo American Indians locally, and the American Indian asked them what they were doing there, and they said, well, we're training to go to the moon. And the next day, the same American Indian, Navajo, came back to them and gave them an audio cassette. And he said to the 2 astronauts, well, bring that to the surface of the moon. And of course, before NASA takes anything on board a NASA spaceship, they have to check the content, and they listened to the cassette, and the cassette was saying, and this was for the inhabitants of the moon, be careful because they're going to take your land. Anyway, this is just one of the stories you find in the book by Lucas Viglietti. A lot of other personal stories. It's a wonderful book, and I recommend it very highly. We're going to go back to the moon. There's no doubt about that. That's a beautiful picture of this taken from the Earth of our satellite, with a nice view of the craters in the along the shadow line of the moon, with the shadow inside the craters. Beautiful picture. Of course, you see very well the Sea of Tranquility here. This is where Neil Armstrong and Buzz Aldrin landed. We're going to go back to the moon. And as you know, we have the Artemis program launched in the United States. And being actively pursued by NASA. This is a political decision, again, taken in 2019. And this is the Vice President, Mike Pence, giving a talk in Huntsville. And the text is in keeping with the SPD-1. SPD-1 is the Space Presidential Directive #1. NASA is charged with landing the first American woman and the next American man on the south pole of the moon. So the idea is not to go to a medium latitude or close to the equator, but on the south pole. I will explain to you later why. Followed by a sustained presence on and around the moon by 2028. So this is a clear plan, and it's pursued very actively in the United States and also other nations as partners. Why the south pole of the moon? I have a pretty high definition picture of the south pole of the moon here. There's a lot of craters there in the south pole. The advantage is that, as you know, if you are anywhere in medium latitude or close to the equator, there is a day that lasts 2 weeks and a night that lasts 2 weeks. And 2 weeks is a long time in the sun, and especially 2 weeks in the darkness, it becomes very, very cold. So there's an advantage of being there because you can find a location here at the rim of a crater so that you'll always be in sunlight and you have a power source with solar rays all the time. That's one advantage. It just happens that in order to find where to locate a moon base, if we want to stay a long time, it's going to be pretty tricky because the moon rotates around itself versus the sun in 29.5 days. And you can imagine if you are there close to the South Pole, you see the sun is going to be moving along the horizon. There will be a slight variation in the elevation because of the fact that the rotation axis of the moon is not exactly perpendicular to the ecliptic plane. So it's going to be going a little bit up and down, but mainly it will be doing a 360-degree rotation close to the horizon in about 29.5 days. So you can imagine with the craters and the shadowed areas, you have to select pretty carefully where you put your base so that you have the illumination condition that you want. This may be an interesting project for IGLUNA 2021, where to put the moon base in order to get the desired lighting conditions. And another thing is there's ice. It's been proven from a measurement from spacecraft on orbit around the moon that there is ice in the craters in the region of the North Pole and South Pole of the moon, mainly South Pole, because there are many more craters in the South Pole. And in fact, Hergé already figured that out in 1954. This is a nice picture of Tintin, who is losing control on the surface of ice on the moon. So in Tintin, on a marché sur la Lune, we could see that already. Now, of course, the Artemis program is being pursued actively, as I mentioned, the development of the rocket, the space launch system, so the capsule, the so-called Orion capsule with the command module or the service module provided by ESA, by the way. This is a pretty significant contribution of the Europeans to this Artemis program. Now, in addition, you have the Gateway, so-called Gateway power supply, logistics support, and there's a contribution of several nations. In fact, the nations which are part of the ISS program contribute to it, like the Canadian, the Japanese, the Europeans, as I mentioned, and possibly the Russian. This is the view of the Gateway with the lunar module here attached to it. Now, ESA has had a plan for a so-called moon village since a few years already. It was launched by Jan Werner, the Director General of the European Space Agency. This is a recent picture that was published on Twitter of a view of the moon village. And you see an astronaut with a European logo on his shoulder. And in fact, Luca Parmitano, one of the Italian ESA astronauts, was commenting on Twitter that this is him here. And of course, all of the ESA astronauts who were selected in 2009, the last selection, there were 2 Italians, 1 German, 1 French, 1 UK astronaut, and 1 from Denmark. And of course, they all think that they're going to go to the moon, and maybe one of them is going to go. But you know, Thomas Pesquet wants to go, and Luca Parmitano, and Samantha Cristoforetti, and Alexander Gerst, who will talk to you in at 5 o'clock this afternoon. He wants to go also, and Andreas Morgensen, the Danish also, and Tim Peake, they all want to go. I will not go because I'm a retired ESA astronaut, but all the 2009 astronauts want to go. One of them will go, I'm sure. I don't know who. Now, in addition to the NASA-led program, Artemis, we have the private companies, especially SpaceX, developing systems that will allow people to go to the moon, in particular the so-called Starship rocket developed by SpaceX, Elon Musk. This is a view of Starship on the surface of Mars. And it's a pretty tough development, difficult development. It's done completely outside of NASA control. It's entirely development made by SpaceX, and it's pretty difficult, but they are moving forward, and SpaceX had a lot of success with a lot of space systems they developed, Falcon 9, the Dragon, the Crew Dragon, the recovery of the first stage of the rocket is remarkable achievement. So we wait and see what will happen with Starship. And by the way, Starship, this new rocket developed by SpaceX, will be used not only possibly to offer possibility for exploration of the moon and beyond, but also to take tourists to the moon. In fact, there has been an agreement signed between the first tourist customer to go to the moon, Yusaku Maezawa from Japan. You see him in the upper left, and this is a representation of a Starship going to the moon. And it looks like Maezawa will be the first non-astronaut tourist who will be going to the moon. But he's going to invite artists. He's himself an art collector, pretty wealthy from Japan, but he wants to invite people to go with him, which I think is very touching. And I have a short video where Mr. Maezawa introduces himself and talks about Dear Moon, his project to go to the moon with artists. It says 2023. It could be a little later than that, but it will happen. Let's go with the video.
Thank you, Elon. Thank you, everyone. Wow. I am from Japan. My name is Yusaku Maezawa. You can call me MZ, please. Finally, I can tell you that I choose to go to the moon. I choose to go to the moon with artists. With artists. I thought, what if Basquiat had gone to space and had seen the moon up close, or saw the Earth in full view? What wonderful masterpiece would he have created? What if Picasso had gone to the moon, or Andy Warhol, or Michael Jackson, or John Lennon, or Coco Chanel? But sadly, they are no longer with us. But this is when I thought there are so many artists with us today that I wish would create amazing works of art for humankind, for children of the next generation. And I wished very much that such artists could go to space, see the moon up close, and the Earth in full view, and create works that reflect their experience. This is a project that I designed and named Dear Moon. Yeah. In 2023, as the host, I'd like to invite 6 to 8 artists from around the world to join me on this mission to the moon. At the moment, I have not decided which artists I'd like to invite. But if possible, I'd like to reach out to top artists that represent our planet from various fields. Lastly, to give you a summary of what I just tried to describe about the Dear Moon. You can see the video from now, please.
has been 50 years since Apollo 8 achieved lunar orbit in 1968. The time has come for civilians to fly to the moon. In 2023, SpaceX will launch the world's first private lunar mission with its spacecraft, BFR. The first passenger will be Japanese entrepreneur Yusaku Maezawa, a globally renowned art collector who believes art has the power to promote world peace. Maezawa made a bold decision. A painter, photographer, musician, film director, fashion designer, Maezawa will invite artists that represent Earth on his journey to the moon. The distance to the moon is 240,000 miles. The crew will spend a week in space. What will they feel when they see the moon? When they see Earth in full view? And what will they create? Their works will certainly become a legacy for humankind. An awe-inspiring, global, universal art project is about to begin. Dear Moon.
Thank you very much. And thank you, Elon, and the SpaceX team for making today possible. I'm very excited. Thank you very much. That's all. Thank you.
Well, as you see, the moon exploration is not going to be only for astronauts, whether they are astronauts of space agencies or commercial astronauts, engineers and scientists, but also for tourists. But I think with the spirit of Mr. Maezawa, inviting people to go with him, people who normally would not think of going to the moon, I think it's a very nice other aspects of I wouldn't say moon exploration, but visits to the moon. By the way, there are a lot of events, particularly here in Switzerland, related to moon. And in the wake of Igluna, we have a so-called hackathon on the 24th and 26th of July. It's organized by a company called Space at Your Service. Chloé Carrière is the head of the Space at Your Service organization. And they have a kind of a brainstorming discussion about exploring the moon and living on a lunar base. As you can see on the upper right, it's going to be all around computers and discussions. Asclepios, again, is experiments of analog astronaut. They were going to do it this spring in the Jura Mountain close to Geneva. It's going to be delayed to next year, but it's an interesting set of actions where we simulate a space mission, but here on the surface of the Earth with experiment to perform and hardship, and there are a lot of features related to astronauts. So try to be there, hackathon 24th, 26th of July, and you have the website in the lower right. Okay, I come to the end. Thank you for your attention. We'll go to the moon, and it will be another extraordinary human adventure. And I think the work that you're all doing, I've been following some of your projects here at Igluna 2020, and I will continue doing so. But you are really going in the right direction. I've been very impressed with the work you are doing, with the depth of your analysis, your also ability to present the result. Continue doing this good work. You'll be part of the future moon exploration. Thank you very much.
So inspiring. As usual, Claude, you make us dream of space and space travels. Thank you. Thank you. We have now time for a few questions.
Okay.
And I have a first one coming from a listener. It's related to the moon base. When would there be a moon village?
Good question. In fact, the idea of the Artemis project is such that we have the first landing, say 2024, maybe 2025. It could be delayed a little bit. And the plan was 2028 to have a so-called quote unquote permanent presence. And at that time, we'll need some kind of a moon base again on the in the South Pole area. Maybe the mission, the 2028, will be a longer mission, like a few months, and we may not need a permanent residence. But I'm sure that by the 2030 timeframe, we'll need really a kind of a moon village with permanent resident capability.
And then another question, could the feather from the drop comparison with the hammer be considered biological contamination of the lunar surface?
It could, although I think that with the ultraviolet radiation that we have from the sun, you know, the absence of atmosphere, it's vacuum and ultraviolet radiation, I think that any bugs would be killed rather rapidly. And I'm sure NASA is always extremely careful about this. We saw the precautions they took when the astronauts came back from the Apollo 11 mission. They were in quarantine for a while. They were waving at people at the aircraft carrier after they were recovered in their capsule, but they were in quarantine for a while. NASA is very, very careful. And I have no doubt that the feather was completely sanitized and was not carrying any kind of germs. But it's potentially it could be, that's true, but I'm sure NASA took good precaution.
Yeah, a lot of interest related to the moon. What technologies need to be developed for a permanent human outpost on the moon?
I think some of these technologies were talked about in some of the projects, typically the power source. Again, if we are on the South Pole and we have a permanent view of the sun, we can have just solar rays, so that would be okay. But if we do exploration in areas which will be in the shadow, we expect the ice to be in shadowy areas. So there we will need a good power source. There was also another presentation that talked about navigation. Navigation is going to be a very important feature. These are two things that I'm thinking about, navigation and power source. And of course, living from the resources of the moon will be a little bit difficult. You can get oxygen from the rock, SiO2. The regolith has oxygen in it. It's not easy to extract, but if you have enough power, and we'll have enough power with the sun in the South Pole, we could extract the oxygen, but you don't need only oxygen. You need more than that in order to have vegetation. So I'm sure that for quite a while, it's going to be necessary to bring things from planet Earth in order to have plant growth and vegetation on the moon. Of course, we'll have to have enclosed environments with the sun being with the proper rate of illumination by the sun. So live from the environment as much as possible is another challenge for a moon base for long duration stays. Power, navigation, and live from as much as possible from the lunar resources.
I have now a very interesting question related to human physiology. If someone is born on the moon and grows up there, could her body adapt to Earth's conditions if she wanted to visit as an adult?
That's an interesting question. In fact, the whole evolution of life was on Earth with 1G. And if we go to a lower G environment, like in weightlessness or on the surface of the moon, it's very pleasant. It's very positive change. But if you are born on the moon and spend a lot of time on the moon, then go to the Earth, suddenly you go to an environment which has 6 times the gravity. And that could be really, really damaging for your body because, again, we talk about long term. If you have evolution of people on the surface of the moon over a long time, but I'm not talking about a few years only, but decades and centuries and maybe millennia, bringing them then to a higher gravity environment will be very difficult. Going to a low gravity environment we know is not a big deal. To a high gravity, I'm not a physiologist, but I have the feeling it's going to be a big problem.
Okay, thank you very much.
It's a really interesting question. I love this question. It's wonderful.
Yeah, it's really interesting. I have another one, not related to the moon. Now, yes, related to the moon, but not in the future. It's related to the Apollo program. if you would have the chance to go back in time, is there something that you would like to recommend to the scientists, astronauts of the Apollo program?
Well, yeah, I mean, it's a completely different world and a fascinating world. And obviously, the geologist is very happy there. And Harrison Schmitt was extremely happy. When I see him close to this big rock, I can imagine what was going through his mind. I think the possible, no, not the possible, but the existence of ice on the moon is something that I would, as a scientist, be really interested to explore. The composition of the ice, how is ice over there different than the ice on the Earth? And of course, as a scientist, you could use the moon as an observatory, whether it's in the visible part of the spectrum with telescopes anywhere in the moon's surface, or radio astronomy on the far side of the moon, so that you are completely in the shadow of all of the perturbing radio radiation from planet Earth. So these are areas of science that will certainly be exploited in the relatively distant future. I don't see telescope in 10 years from now on the moon, but maybe in a few decades it will happen. So geology, and especially the existence of ice and other material than the regolith on the moon, and the possibility to use this as a natural space station for astronomy and astrophysics.
Thank you. Again, a question related to future of moon exploration. Do you see the commercialization of space exploration to be a good thing for space agencies, or do you feel that it may reduce their significance?
Say again the question.
The question is related to the commercialization of space exploration.
Yeah, okay.
And if it would reduce the significance to the space agencies.
I think that there will be a good matching of the activities of the private space agencies on one hand, where many of them will be, or private companies, let's say, many of them will be pursuing commercial goals and pure exploration. We see this already with work together between NASA and SpaceX, and also Boeing with the next Starliner capsule that will be used to take people to the International Space Station. So you have commercial companies and you have NASA working well together. And now, as far as the commercialization is concerned, and maybe having factories and producing materials on the surface of the moon that could be of interest, like additive manufacturing for building spacecraft that will be launched from the moon surface to go further away in the solar system. I think the work together of commercial companies by definition, they try to make money in a way, but also produce products that are very useful along certain objectives and goals. I see a happy working together of space agencies like NASA, ESA, Roscosmos, and others, and commercial companies, including for commercial actions and manufacturing. I'm not concerned about that.
Yeah. Now we have question related to people interested by space career. What advice would you give to someone that wants to go to the moon?
Train. Be ready for the unexpected. In a way, this is something that we astronauts do all the time. We train relatively little the nominal mission, but we train the action that have to be done in order to recover from abnormalities or semi-catastrophes or real catastrophes. If you want to have peace of mind during your space mission, if you want to avoid stress, you need to be well prepared, not only for the nominal mission, but for covering all kind of abnormal situations. This on one hand, but on the other hand, you need to be sure that you enjoy it. And for me, I was always impressed with the fact that on one hand, you have the professionalism, the deep preparation, the knowledge you have in your head, or you know where to find the information. By my time, it was more in books than on computers in the 80s and 90s of the shuttle program. But you want to be non-stressed because you are well prepared, but at the same time, you want to enjoy it. And I remember on my shuttle flight, which were always very compressed with work because they were short mission, typically 10 days, and we had a lot to do. But when we had sometimes 1 or 2 hours of free time, it was absolutely wonderful and we enjoyed it. So be prepared to enjoy it, because the views, whether you're on low Earth orbit or going to the moon, around the moon, on the surface of the moon, the view is always going to be absolutely amazing. So enjoy it, but do your work professionally and be well prepared.
Maybe I jump. You were speaking of books, and somebody asking of these books, which one do you recommend to read? Which one inspired you the most?
I talked about Carrying the Fire by Mike Collins. It was an enormous inspiration for me. I mean, the whole spirit of the Apollo program, and also the transition from being a fighter pilot or test pilot at Edwards and becoming an astronaut. As you know, there was a lot of questioning of the test pilot at Edwards versus the astronaut who were going to be in cans, shot to space without having really the control, rotation and translation, hand controller, and being in control like you are in control of an airplane. So this whole story is very well described in Collins' book, and also the preparation for the first mission to the moon, Apollo 11, the mission itself. And there are a lot of philosophical thought at the end of the book about the future of the space program and space exploration. Carrying the Fire by Mike Collins is a wonderful book. And again, I recommend the book of Lucas Viglietti. I have it, and read it. You don't read it necessarily from beginning to the end in one shot, but you read some chapters. It's a wonderful book. It's all of the human aspect of the Apollo program. You have the chapters with Apollo 11, 12, 13, and so on until Apollo 17, and some philosophical ideas also expressed. These are two books that are very highly recommended.
And maybe a question on another book, which is probably also very inspiring. It's how visionary was Tintin's journey to the moon at this time? Was it considered as a crazy distant future? How did Hergé knew about the ice on the moon?
Well, I think he imagined there would be ice on the moon. I think it's obviously there were no indications there that there was, because it was only by going around the moon on spacecraft and analyzing the composition of the moon surface that it was detected the presence of ice in craters on the North and the South Pole. So it was just his imagination. Hergé had an enormous amount of imagination. If you look at all of the books by Tintin and Milou, Capitaine Haddock, Tournesol, and so on, it's an enormous amount of imagination. And I think he released his imagination about space travel, and also he imagined this idea of a rocket that has a constant thrust with a nuclear engine. You could not do this with a chemical engine because you would use too much propellant, because you have a low specific impulse and efficiency. But with a nuclear rocket engine, you could create artificial gravity on the way to the moon. You accelerate, and at some point you do a manœuvre de retournement, you flip over 180 degrees, and you slow down for a soft landing on the moon. That was a bright idea, really bright idea. When you it's read and look at the same time, because it's cartoon, so there's a little bit of text, but there are a lot of drawings. I've been showing some of these drawings because they inspired me very much. You see the sky with the stars, and this landscape partially lit by the sun with very high contrast. Whatever is in the shadow is very dark, whatever is lit by the sun is very bright. So it's just beautiful. I love this book, and again, it's all the imagination of Hergé, the whole story, as well the technical aspect of the rocket and the propulsion system to go there, and what happened on the surface of the moon with the ice.
So thank you very much, Claude. Unfortunately, we arrive at the end of this hour. So really, thank you for this inspiring presentation, and I'm looking forward to seeing the future moon and beyond space missions. So with this, we conclude the present session, and please stay tuned for the presentation of the Horizon mission by the German ESA astronaut Alexander Gerst, which will be live streamed today at 5 o'clock Swiss time. Please check on the program, as Alexander Gerst's presentation will be on another YouTube stream. For all of you watching through YouTube, please fill in the survey in the video description below. Your answers are very valuable to get to know you better for our future events. Thank you and see you soon. Bye-bye.